Good morning, good afternoon, good evening, whenever you may be. It's time for another exciting day of science here at ACE Academy as we are live from the Brenna Bunker somewhere in the quarantined southeast United States. And here we go, another fabulous day, not sitting in a classroom. But yet, here we are in a classroom, as it so much may be. All right, so here we go again. Hope everybody's doing great and staying safe there wherever you are. Hope everything's doing well. Remember, when you watch these videos, go down in the comment section and say hi in the comments. That's your attendance for today. And also, please give us a good thumbs up and like, and subscribe to the channel. Geez, I'm starting to sound more and more like these YouTubers every day, aren't I? Anyway, so today we're talking still 8.E.1 talking about the hydrosphere. Now, the next thing we're going to be talking about is I can explain what happens in an upwelling. Well, first thing we got to do is define what an upwelling is. An upwelling is a phenomenon that has masses of surface water moving. When these masses of water move, colder, denser water from below rises to take the place of the water that is moved away. It's similar to convection, which we've talked about in 5th grade and 7th grade, but it is not the same. Convection heat from the bottom side is making a fluid rise, and the cool fluid descends and takes its place. Fluid, air is considered a fluid when it's moving around. So with upwelling, it is wind that drives the most. And yes, wind. How might wind drive water moving from a place where wind cannot reach, you might ask? I have an answer for you. It's called Ekman transport. Well, that tells us a whole bunch, doesn't it? So anyway, so this is one of the more confusing things. You just have to go and listen to this. You may have to play this twice to actually get the entire picture. But this is the first time I was going through this stuff, and I'm just going, all right, I have to figure this out, better, because I don't understand how in the world wind blowing in one direction can make water move in a different direction. So that was just a thing that caused me some consternation until I went and figured it out. So we got this little graphic right here. So the wind, typically where we see these upwellings are along coastlines. And so the wind, so imagine the coast is over here along this line that the wind's blowing on. So the wind is blowing parallel to the coast, parallel. So here's the coast, here's the wind blowing along the coast. And so what happens is the wind blows along the coast, it blows along the top of the water. And so when the wind blows along the top of the water, it creates a friction force. And that friction force ends up creating a surface current, the water on the surface that moves at a 45-degree angle to the angle of the wind. Well, then allows it to move water that way if it's the surface current's this way. So then you're going to see this spiral of arrows down here going down deeper, and I'm going to explain why that happens. Okay, so now we have a picture to confuse us even more, right? So I'll continue to explain. As usual, sciencey things get named for the people who discover them. This effect is no different. 1902, von Walfried Ekman described the process by which wind blowing across water causes it to move. Well, if you've ever just blown across the top of a glass or the top of a bowl of soup as you're trying to cool it off, I mean, you can see little waves that form when you blow on it that go immediately away from you. So again, you would think the wind blowing something would move it in the direction of the wind. So that not really, here's again where science just goes, it's not quite how it works. So now these actions take place primarily in an area along a shore. There must be a persistent wind that blows along a shore, such as trade winds. I mean, this is not something that happens just every once in a blue moon. I mean, the wind has to be consistent and happen pretty much all the time. So the only time we see places like that are where the trade winds happen, trade winds being areas where the Earth's motion produces the Coriolis effect, which goes into sorry, that was somebody wanted to FaceTime me. I'll have to get back to them in a second. So the winds influence the water by friction. Remember that gases that make up the atmosphere are made up of atoms and molecules. When the wind blows constantly, the molecules of gas scrape along the surface of water and friction occurs. This interaction between the air masses and the water produces a force with a vector at 90 degrees to the wind direction. Well, the mass of water which it affects is the top 10 to 100 meters of water. All right, so 100 meters, that's pretty deep. it's a short distance to run horizontally, but if you're diving, 100 meters is pretty deep. Wait a minute, you say, how can it produce a motion that is at a right angle to the force applied to it? Well, here's where things get fun. You just have to accept the explanation because the reasons get confusing. The Earth spins on its axis. The spinning produces an effect in the wind and water known as the Coriolis effect. Coriolis effect produces a force vector counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. So with that being said, so Coriolis effect produces this spiral of arrows down to, that you're seeing here. This is the view from straight up over the top. This is the kind of the 3/4 view. So the wind is blowing this way, and the friction of the wind creates a surface current that is at a 45-degree angle to it because of the Coriolis effect. Well, that current, again, as that water starts moving, it has friction on the layers below it and drags the layers below it with it. But again, the Coriolis effect of the water of the Earth spinning, every kind of segment as you go down has a little bit more of an angle off to, in this case, the right. But as you add up the sum of all these arrows, and you look at the one all the way down here at the bottom, it's literally going the entire opposite direction of the wind, really. But you add up the sum of all these force vectors, and you get a direction vector of this way. So this is direction of Ekman transport. So with our picture here, the smaller arrows are spread out from the center, the result of the Coriolis effect. As it shows the net, meaning all added together, effect is a mass of water moving in a 90-degree angle or perpendicular to the wind. So when the wind blows parallel to a coastline, the water will be pushed away from the coast. Something has to fill in where that water just was. And the thing that fills it in is the water that comes up from below. This rising water is cooler and more dense. It carries with it nutrients in the form of sediments, which contain decaying organic remains, and suspended minerals such as nitrate, phosphate, and silicic acid. These nutrients result in huge increases in marine producer growth. Producers are what? They get their energy from the sun. Phytoplankton are the largest part of these producers. In nature, when there is a surplus of an organism, guess what? The things that eat that organism end up having their numbers increase as well. So the predators of the organism increase in numbers. At each trophic level, more energy in the form of food is available, the higher the number of the organisms that exist. The areas of the major upwelling around the globe account for nearly 50% of the ocean's biologic activity. There are 5 major coastal upwelling systems. So now, I'm going to show you these, but you don't have to memorize these 5 systems. But you do have to memorize what an upwelling is and the fact that as the surface water moves away, going, away from the screen, from over here, the wind is blowing parallel to the shoreline, the surface water gets pushed away, and this colder, deeper, water from deep down with all these nutrients in it drags up, brings those nutrients with it, causing more biologic activity. The phytoplankton grow, the things that eat the phytoplankton grow, the things that eat the things that eat the phyto, and so on and so forth. So there are 5 major coastal upwelling systems. Canary Current off of Northwest Africa. So here's Northwest Africa. Here's the Africa. Here is Africa. And you have the current, and you see these, and here's the temperature map here. So, warm water, relatively warm water, but yet you see these little blue areas along the edge. That's that cooler water coming up from deep down in the ocean and bringing all those nutrients with it. So here's the Canary Islands. That's why they call it the Canary Current. The current, the winds blow parallel to shore, sucks that water out this way, causing the upwelling. So there's the Canary Current off north of Africa. The Benguela Current off of southern Africa. So here is, Namibia, excuse me. And then here, this is actually South Africa, the country. And so you see, these 3 things. So it says sampling location. So there's where they took our samples from. The biomass. Biomass is the amount of living stuff. So the darker the number, the more biomass is being, so that biomass is that's that nutrients and stuff being brought up from the deep. You see how the darker purple here is, and guess what? So production, in fishing kind of things, darker the better. The higher the production. Look at those dark spots that correspond with these darker areas of biomass being brought up by that upwelling off the coast of South Africa. Now here we have the California current, which this is the southern coast of California, Point Concepcion, Monterey. So this chart shows vertical velocity. So vertical velocity, high vertical velocity would be the more red it is. Look at how red this is along in here in this coast area. So that's the vertical upwards velocity of the water. So upwelling, dragging those nutrients and stuff up. We have the Humboldt current down here. This is off the west coast of South America. So this is the one. The funny thing is, this is the same coast where the guys, they discovered El Nino, the El Nino, the baby they called it, because they fished this area because of the currents here off the west coast. Permanent upwelling right there, right there, right there. This area right there here off the coast of Peru. But that's where they named it, the El Ninos, because they noticed the change in the seawater and the fishing that it affected. And so every once in a while, because again, El Nino cycles on a 2 to 7 year cycle, they would notice this, the water be kind of warmer, and it would change the fishing, and they called it El Nino, the baby, the boy baby, because that's yeah. And then La Nina is the opposite side of it, the girl. And then let's see. Then lastly, the Somali current, which is off of the east coast of, here's Africa again. Here's the sea. Then here we have Ethiopia and Somalia over here. And so they have the Somali current and the Somali upwellings here off of the west coast, the east coast of Africa. There's, country of India. But here's where this upwelling occurs off the east coast of Africa and there, the Somali upwellings. So once again, upwellings are places where the ecton transport, E-K-T-O-N, ecton transport takes wind energy that's parallel to the shoreline and causes water to move at a 90-degree angle to the wind, which in this case drags it straight off the shore, and then colder, deeper nutrient water from down below fills in the place where that upper water left. Because you can't just have a big hole in the ocean because the water went away, something has to fill it. So it drags this nutrient-rich deep water, colder water up, and like I said, causes about 50% of the ocean's biological activity occur in these 5 upwelling areas around the world. So it's anytime you see upwelling, there's going to be huge amounts of biological activity there. Okay, so like I said, short lesson today on upwelling, but again, you may have to go wander back through this to really get a grasp on this ecton transport thing, where the wind blows one way and the water goes a completely different direction. It's not something, it's only due to so why does the ecton transport, why does it exist? Coriolis effect. Because the earth is spinning, it causes things to rotate, even though they're traveling in one way. So that's why hurricanes rotate one way in the northern hemisphere, and then storms in the southern hemisphere rotate the other way. Coriolis effect. It is a huge deal in weather. So remember that. So ecton transport. There's the dude's name. Wait, undo. So Ekman. Ekman transport. Why do we have upwelling? Ekman transport. What is upwelling? It's where colder, denser water anyway. Upwelling is a phenomenon that has masses of surface water moving. When these masses of water move, colder, denser water from below rises to take the place of the water that moved. Reason why? Ekman transport. So, great lesson. See you guys around. Make sure you do your do now questions, and there's going to be a little bit of a. We'll see if there's anything to do today. Make sure you like the video. Make sure you comment in the comment section, and subscribe to the channel. We'll see you guys next time on ACE Academy 8th grade science.